Welcome everybody to the seminar today. It's a pleasure to welcome Marshall Burke, who is an associate professor in the Department of Earth System Science at Stanford University, where he is also the deputy director at the Center on Food Security and the Environment. Marshall's research focuses on social and economic impacts of environmental change and on measuring and understanding economic livelihoods across the developing world. I tend to think of Marshall's work as focusing on big questions, using big data, using empirical methods that are very carefully executed. And one of the interesting things about Marshall's research is that he publishes both in economics and scientific journals. And he holds a PhD in agricultural and resource economics from the University of California, Berkeley. It's a pleasure to welcome him here today. He's going to be speaking to us on understanding the causal impacts of climate on human conflict. And before I turn it over to Marshall to start his seminar, I'll just say that he welcomes questions or interruptions, clarifications, or comments throughout the seminar. You're welcome to just raise your hand feature, and he'll either see it and respond, or I'll just give him a little nudge to focus on your questions and keep on with his presentation. So without any further introduction, welcome Marshall, and we look forward to your presentation.
Great, thanks a lot, Matt, and thank you guys for having me. Too bad couldn't make it in person. Hopefully sometime in the future, but thanks a lot for coming on what I hear is a very rainy, blustery day in New Haven. So let me share some slides. Yeah, so as Matt said, this is very much work in progress, and would love to get your feedback and your comments and questions at any point. So please do jump in and interrupt. It might be hard for me to see the hands up, so please be aggressive in intervening. I'll try to also leave some time at the end for additional questions and conversation, because I think there's a lot of ways we could take this work. So as Matt said, this is going to be a talk, and again, really work in progress, where we are trying to take a big picture look at the relationship between changes in climate, broadly construed, although today I will focus mainly on temperature changes, which are perhaps the best studied and best observed, and its potential impacts on different types of conflict around the world. And I'll try to define these more precisely in a moment. But we are going to be casting a wide net, both in terms of how we think about climate and in terms of how we think about conflict. And we are going to be using data, as much data as we can assemble, either on our own or from existing published studies, to try to characterize whether there's an overall relationship on average and how that relationship might differ across settings. And then to use that backward-looking evidence from recent history to try to say something about what the world might look like going forward as the climate warms and as economies hopefully continue to develop. So this is joint work with two Berkeley collaborators, Ted Miguel and Saul Shang, three, Joel Ferguson. So Ted and Saul are on the faculty there. Joel Ferguson is a great graduate student in the ARE department, and Jerry Min is a RA who works with me here at Stanford. Okay, so if I can advance my slides. I think I'm speaking to a crowd that thinks a lot about conflict and its consequences. So maybe what my motivation here will be a little bit preaching to the choir. But a lot of people don't think a lot about conflict, but they do read Steven Pinker's popular press books. These are very popular, and I'm sure many of you have read this very nice book, Better Angels of Our Nature, subtitled Why Violence Has Declined. And in this book, Pinker really takes a very long view, century, millennial scale view on human violence, and argues, I would say, fairly persuasively that over the very long run, we've seen a pretty remarkable decline in humans being nasty towards one another, violent outcomes. And really what he can study well here is more individual level conflict, homicide, basically. A lot of his evidence comes from homicide, but also has relevance for broader group scale conflict. So a lot of people read this book and think, well, conflict is sort of a thing of the past, right? Yeah, maybe we still see some, but it's gone down substantially, and we're much more peaceful than we were decades, centuries, millennia ago. That might be true, but what is also true is if you look in a more recent era, we have seen a not monotonic, not completely steady, but overall increase in various types of conflict. So I apologize that the x-axis here is hard to read. The data here go from, it's the post-war period, 1946 up to 2020. And what you see in the different colors here are the number of conflicts around the world of various types. So these have sort of clinical definitions, and in the darker blue is what's officially called a civil war. That is a conflict in which 1,000 people died, and where one of the combatants is a state. So think of this as a state either fighting another state, or more typically fighting some other group, some other non-state actor within the country. So the wars are the very large one that kill over 1,000 people, and the lighter colored reddish ones here are minor ones that lead to at least 25 battle deaths. Often these are associated with many more deaths beyond just the battle deaths, but this is how these are counted. And sort of no matter how you count these, the number sort of peaked in the mid-90s after the end of the Cold War, and then declined afterwards. Steven Pinker wrote his book, but then in the last decade, these have come back up pretty dramatically, and now have reached totals that exceed what we saw during the most conflictual post-war period, which was the early 90s in the world. So now the annual number of conflicts is at an all-time high post-World War II. So Pinker might be right on the long view, but in the shorter view, conflict is certainly not going down. If anything, it's going up. You see conflicts around the world. So this is not just concentrated in one area. Here's the map from 2020. So these are data from the UCDP. For whatever reason, the Scandinavians have really committed themselves to counting conflicts around the world. So all our great data come from different groups in Norway and Sweden. This is from the UCDP, and I'll show you various analyses using the UCDP data. Here's just a recent figure they put out showing where these state-based conflicts are happening really right now. So this is from last year. Many of these are ongoing. And as you can see, these are pretty widespread around the world, right? They're not just concentrated in one region. So conflicts going up, spread around the world. We are in a high conflict period right now. And again, I think for this crew, this stuff is well known, but conflict is bad on its own, but it's also bad because it worsens many outcomes that we care about. So if you think about the number of forced displacement, conflict is a leading cause of forced displacement around the world. And no surprise, as conflicts have increased in the last decade, we've seen a steady increase in the number of people either internally displaced or crossing borders to escape conflicts. Again, this is not just conflict driven, but conflict has been a large driver here. You can also think of other outcomes, economic outcomes or food insecurity outcomes. So food insecurity or the prevalence of undernutrition was on a steady decline for many years, again, until about a decade ago, and now is flattened down. And if anything is on the rise, the last year here is mainly COVID related. But a lot of this flattening, I think, again, can be attributed to the increase in conflict, right? It's reversing the progress that we've seen against food insecurity around the world. Okay, so that's conflict. So why might climate be at all relevant here? Let me motivate this in a couple ways. First, by using some quotes from luminaries from the recent and distant past. So here's President Barack Obama when he got elected and then immediately won the Nobel Peace Prize. Here's what he said during that speech: "The world must come together to confront climate change. There is little scientific dispute that if we do nothing, we will face more drought, more famine, more mass displacement, all of which will fuel more conflict for decades." So here's Obama over a decade ago making a very strong empirical claim relating changes in climate to conflict outcomes. We can go back further. If I can advance my slide, here we go. Romeo and Juliet. So now we're going back centuries. If you remember Romeo and Juliet, roughly, there's the good guys and the bad guys. Here are the set of good guys talking to each other, Benvolio and Mercutio. These are good friends of Romeo. This is midway through Romeo and Juliet. So they're out in the street and it's a very hot day. So I pray thee, good Mercutio, let's retire, let's go inside. The day is hot, the Capulets, the bad guys, abroad. And if we meet, we shall not escape a brawl, for now these hot days is the mad blood stirring. So basically, Shakespeare is saying here, there's just something about it being hot that causes us to want to fight each other, right? And sure enough, they don't go inside. All hell breaks loose. Many people die, right? And so Romeo and Juliet and Shakespeare in general is typically not read as empirical work on climate and conflict, yet I would argue there's some early evidence here in Romeo and Juliet. Okay, so why might this actually matter? So if we go back to these quotes, you can see Obama, I would say, making perhaps an economic argument between changes in conditions, economic conditions, livelihood conditions on the ground, and a propensity for conflict. So that's one potential mechanism that might link climate and conflict. So if we think changes in climate affect livelihoods, and we think changes in livelihoods affect the propensity for conflict, then you could see a natural pathway from climate to conflict. Shakespeare is making a very different argument, right? It's not about economic conditions here. It's just something about the physiological response to heat. And I think if we introspect a little bit and you just think about how you feel on a hot day, potentially grumpier, you might think, can that lead to changes in certain types of conflict outcomes, just a physiological response? And I'll show you some evidence that actually that might be the case. So there are multiple mechanisms. So again, the Obama story is perhaps about economic conditions. The Shakespearean story is perhaps about sort of physiological or psychological response. There are other stories, and again, I'll get to the literature in a second that has looked at this. One is more a migration story, so maybe relevant to the research of folks at the Macmillan Center here. So climate change can drive migration. There's good empirical evidence of that, and there are many studies suggesting that migrants in various ways, as they come into new areas, can perhaps precipitate conflict with people in the receiving location. Another story, long-term story, is about grievances. So perhaps changes in climate can amplify or multiply existing grievances between groups as they alter, again, economic conditions on the ground. So that's yet another story why climate might matter for conflict. Differentiating these stories is something we're going to try to do in this work, and I'll get back to that towards the end. Okay. I want to emphasize from the very beginning that we are not environmental determinists here. Nothing we're going to study empirically links between changes in climate and conflict. None of this should argue that climate is the only nor the most important, quote unquote, cause of conflict. Clearly, there are many other things that determine whether or not a conflict happens. We are going to try to isolate the climate component of these causes, right? So again, we're not being determinist here. We're just trying to understand empirically, is climate an important driver of observed conflict that we see? Okay. And so I want to be very clear about this. But it could be an important, and basically this is an exercise to try to understand how important it is. The Defense Department now talks about climate as a threat multiplier. So again, there are many existing threats. You can see sort of between the arrows here, and changes in climate might alter or magnify those threats. So policymakers are using this language, and this could have specific implications for interventions that we might undertake, right? If climate is an important cause, that might change actually what we do on the ground to prevent future conflicts from happening. So that's why we're going to study it. Okay, so what do we actually know about this? So it turns out there's actually a very large literature on this that's really accelerated in the last decade. So with Saul and Ted, almost a decade ago now, we did what we thought of as the first sort of empirical meta-analysis of the existing literature. Back then, there was a few dozen studies. And here we're really focused on the quantitative studies, studies that used longitudinal data for the most part to study empirical relationships between climate and conflict. And so this was published, again in 2013, and we argued was the sort of best empirical summary of relationships in the literature. So here in this study and in the update that I'm going to show you, we really focused on settings where we could isolate the impact of climate from all the other potential causes of conflict, right? And so actually doing this in a meta-analytic way requires going back to the primary data in many of these studies and reanalyzing them in what we would think of as statistically responsible ways, using a statistical methodology that I'll talk about in a second, that again can really isolate the impact of climate from all the other things that could be causing conflict. So the findings from this earlier meta-analysis, again, a few dozen studies, we found that increases in temperatures and in extreme precipitation, but again, the temperature signal seemed the strongest, led to increases in both interpersonal conflict. Think of this as violent assault or homicide in the worst case outcome. So two people having an incompatibility, and a larger increase in intergroup conflict. So think of this as the civil conflict, civil wars that I showed you before. So robust, statistically significant average relationships between climate and conflicts across the studies that exist. So that was almost 10 years ago now. There has been an immense amount of work on this in the last 8 or 10 years since we published that. So we want to revisit this earlier analysis. We want to understand whether our earlier results still hold up, given again, the large amount that's been published since. I think what's interesting and what made us want to revisit this is not only that, but that many new types of conflict and violence around the world are being studied. So I can show you some results on that. And because we have a lot more literature and a lot more data, we have new capabilities and opportunities to understand the mechanism linking climate and conflict. That was not something we could do a very good job with in the earlier study. And of course, that's very important if we want to think about interventions. And finally, again, we've had a decade with a lot more conflict and a decade where we've seen lots of warming, right? So you would think it's a decade where we might be able to learn a lot empirically about the relationship between climate broadly and conflict. Okay, so here's what we're going to do in this study. Again, this is mainly a meta-analysis, although we are going to do some primary data work as well. So we are going to update our earlier meta-analysis on what we will call intergroup conflict. So again, think of these as groups fighting groups. This is civil conflict, civil war, as well as some other outcomes I'll show you in a moment. So we're going to distinguish that from interpersonal conflict. These are individuals potentially harming one another, homicide, violent assault. We are also going to add in the third category of self-harm. And so this is, you could think of, instead of interpersonal, intrapersonal conflict. There's been a lot of work on that recently. Show you that. Number 3, we're going to dive deeper into mechanism, and I'll show you what we've gotten done on that. We're far from having a full story here. I'm going to look at one potential mechanism that we can observe and try to measure. And finally, and I won't get to this today, we want to think about potential climate impacts, both in understanding what climate scientists call attribution. So what of the existing, the changes that we've already observed in conflict, what can be attributed to changes in climate? And second would be a projection, a forward-looking thing. So what might we think would happen in the future, given what we've observed in the recent past as temperatures continue to warm? So I won't do either of those today. I'll sort of try to set that up, but that part of the analysis is not complete. Okay.
Marshall,
Yeah.
can I just jump in with a quick question?
Yeah, please.
Maybe you're going to get to this, but one just thing I wonder, and I thought about this with the first slide that you had with the trend in conflict over time. Just over time, to what extent does like the data that we know about the increased prevalence of violence relate to just more comprehensive and sophisticated ways of collecting data? Yeah,
it's a great question. So one thing you would very much be worried about is time trends for various reasons, but one, just a reporting artifact, basically. We have better data on where and when conflicts occur, and so we record more of them over time. Yeah, that's absolutely right, and I think that is definitely part of some of these data sets. So the way many of these climate event data sets work is they scrape basically news reports. So they look at local news reports, either from media organizations, from humanitarian organizations, and then code these events as conflicts or not, using existing data that they can find or estimate or put together on how many people were affected, right? And it has to be the case that our information from local news organizations or from humanitarian organizations has improved over time, leading to some of that trend. So we need to be very careful about that exact problem and think about how to control for the possibility that of an overall secular increase just due to reporting. And so in the analysis that I'm going to show you, what we can do is try to control either across all the data or in sort of a local way for any sort of secular, what we would call time trends, right? Anything else that's driving trends in conflict over time that might not be climate. And again, reporting is one of the things we're going to worry about. Yeah, so you're exactly right. And hopefully we're doing a good job trying to account for the reporting part of it. Okay, so again, this is a quantitative meta-analysis. We are not going to focus on a very large and important case study literature thinking about conflict. We are going to focus, for better or worse, on quantitative studies that, again, statistically relate changes in conflict outcomes to changes in observed climate. And in particular, we are going to focus on studies that can observe fixed populations over time as the climate fluctuates. So sort of a standard example here, perhaps. So you might think of, let's compare Norway to Nigeria, right? So Norway is historically been fairly peaceful, at least in the past half century. Go back further, less the case, but think in recent era, Norway is fairly peaceful. Nigeria has unfortunately experienced a lot of conflict. Norway tends to be quite cool. Nigeria is quite hot. So a naive analysis would say you get more conflict where it's hot because Nigeria has more conflict than Norway, right? Obviously, that's not a great comparison. We might think that Norway and Nigeria differ in all sorts of other ways other than just their average temperature. And so that could be a very confounded comparison. So we do not include studies that make those sorts of cross-sectional comparisons. Instead, we want to use studies that don't compare Norway to Nigeria, but compare Nigeria or some other location to itself over time as it experiences hotter versus cooler or wetter versus drier years, right? Again, we're going to use within location variation over time and controlling, as Matt brought up, for any other thing that could be trending in a common way across all units over time. So if we think this sort of reporting effect is sort of similar across a lot of different units, let's say all countries in Africa sort of saw an increase in conflict just because we're now reporting on more conflict in Africa, we're going to sort of control for that by accounting for an Africa-wide trend or an Africa-wide year fixed effect in the parlance here. So the sort of technology we're going to be using here, the statistical technology, is panel fixed effects regression. I didn't put up any equations here. More than happy to go into the details on this. And the comparisons that come out of these are basically the ones that are on the slide here. There are other things you want to do in these regressions. So we're actually going to push the data pretty hard. We want to account for potential lagged effects of temperature as well. Those could go in two directions. It could be the case that multiple years of negative climate exposure increases conflict. So you want to account for both current and previous exposure. It's also the case that a hot year last year could have caused a conflict to occur that was already going to occur anyway, right? And that's what we would think of as displacement. So if you think there's potential displacement going on, and this has actually been well studied in the heat and mortality literature, you need to also include lags of your climate variables. Again, I didn't want to go into too much detail on that, but happy to talk about the statistical details there. In any case, we're running panel fixed regressions. We call these distributed lag regressions, where we're including multiple lags of our climate variables, and we're adding up the effects across lags to generate the overall effect. That was the only statistical sort of dive I had there. Again, happy to talk about that one. Okay, so quickly, wide meta-analysis, and then I'll show you some actual results here. What can this and what can't this tell you? So it cannot tell you anything about specific conflicts, all right? So this sort of statistical approach and the meta-analysis we're gonna do on top of it cannot tell us that climate caused the Syrian conflict, right? It just can't. What it can say instead is, on average, do changing climatic conditions make conflict more likely, right? And again, typically not individual conflicts. It has little to say often about individual conflicts because the counterfactual, the unobserved counterfactual for that conflict is, again, unobserved. What it can say is, in years that are hotter or drier on average, are you more likely to see conflicts? And does that effect differ as a function of other things we observe? So that's what we're going to be able to do. Okay, so again, and the reason for doing this is we think at least threefold. This might be able to help us anticipate the future impacts of climate change. So there's an important climate change question here and thinking about the overall costs of climate change or how much we should mitigate climate change, right? if increased conflict is a consequence of a warming climate, then that's something we should account for when we make policy decisions about how much to mitigate. It might help us understand the underlying determinants of conflict, right? If we do see large increases due to climatic changes, that might help us hone our theories about why conflicts happen and what to do about them. And again, finally, in the what to do about them sense, it might help us identify interventions that have at least average benefits, if not necessarily benefits for specific conflicts, because again, it's going to be hard for us to say something statistically responsible about specific conflicts. Okay, so here's our study sample. So again, we cast a broad net as possible across many different domains. So these are papers from economics, political science, geography, criminology, anthropology, marketing science. So think of this as a very cross-disciplinary look. This is, months and months of Google Scholar searching and tracking down citations of citations. We include working papers. As you'll see, we often have to go back and reanalyze these data. So we have contacted dozens and dozens of authors, requested their data. If they're willing to share it or if they're not ready to share it, we've requested them to run additional analyses that we want to see run. Many have cooperated. And so the studies that are included are typically ones where we can either access the data or get authors to run the fixed effect specification that we want them to run. So across the different types of conflicts, we look at conflict outcomes. We look at right now, we have 68 studies in our sample. This is likely to grow over time. And most of these were published since we did our last analysis, right? So 70% of these have shown up more recently. Here's the sort of time trend of our when studies in our sample were published. So a lot of activity on this in the last 5 to 10 years. And on the right is, I know we're not supposed to show pie charts. It's a sort of a dirty pleasure of mine. I get to show a pie chart. This is the geographic sample. So it's really spread out around the world. So a lot of our group level conflict is going to come from Africa and Asia. Much more of our individual level conflict observations is going to come from wealthier countries in the OECD. And we have multiple countries, sort of 20% of our data really take a global look, so that look at more than one continent. Okay, pause there for a sec. Hopefully the overall inclusion criteria are clear. So again, this is going to cause us to not look at least in the meta-analysis sense, a lot of important qualitative work thinking about the causes of conflict. So this is, again, a quantitative meta-analysis. Okay, so initial questions we're going to try to answer. What is the average effect of climate? And that, I'm saying that in quotes. Think about this is warmer temperatures or more extreme rainfall. Those are the two main types of climatic variation that we're going to be able to look at. So what is the average effect of a change in climate for a given type of conflict? And then we're going to use those 3 different groups of conflict. Number 2, do effects vary across settings? So you might see point estimates in different studies that look different. Are those truly different, or are the differences attributable just to sampling variability, to statistical noise, right? So if we want to say that studies are different and finding different effects, we need to be able to differentiate those two things, true underlying heterogeneity from sampling variability. I'll show you some Bayesian techniques we use to do that. And finally, can we understand and predict why effects vary over settings? Okay, so again, 3 different types of conflicts. I'm going to show you 3 figures that look like this. Each line here is a study. The print here is very small because we have lots of different studies. Maybe not the best way to show these data. So each line here is a study. The solid line is the point estimate of the effect from that study, the relationship between climate and conflict. You can see the 0 line here, sort of roughly equivalent to the blue line, right? So anything to the left says warming temperatures or more extreme rainfall is reducing the likelihood of conflict. And anything to the right of it is saying the opposite. Warming temperatures increase conflict, or more extreme rainfall increases conflict. Okay, so this is intergroup conflict. And again, we've cast a pretty wide net and dumped a lot of things into this intergroup bucket. So we are looking at civil wars, we are looking at riots, we're looking at coups, we're looking at terrorist events, we're looking at communal, so non-state-based conflict. And those are sort of listed along the outcome column here, if you can see that. And finally, again, here are the locations. So these vary from pretty small scale locations. So studies just looking at, one corner of sub-Saharan Africa or looking at Syria, to global level studies that use country level or gridded level data from around the world. Okay, so you see the point estimates there, and underlying the point estimates are the confidence interval. And so these are bootstrap confidence intervals where each little transparent line is a different resample from that same study. So we are interested in the statistical uncertainty for each of these studies. And so we are going to basically resample the data from each of these studies and re-estimate that effect many, many times. And so studies where the confidence intervals are narrow tend to be ones. So here's one, if you can see my cursor, where you see a lot of mass right around the point estimate. Many of these other uncertain studies, especially the ones with very large effect sizes, turn out to be quite uncertain, right? They have large point estimates, but the confidence intervals on these studies are quite large. And again, I will note that the estimates shown here are often not the ones that you would find in these studies themselves. We have reanalyzed these data, and often we come up with very different answers than what was in the published paper. And that's because we are running what we argue is the quote unquote correct statistical analysis for studying this relationship. So this includes some of our own earlier studies. Here's one of mine, Burke et al. 2009. We had a very statistically significant result in that paper that we published. We have gone back and reanalyzed it, and it is much less statistically significant than what we had published before, right? I think, so we're updating our own work as well. Okay.
Marshall, if I could just jump in with another question. Like,
yeah, please.
I kind of see, like, in a generic sense that doing your panel fixed effects approach would be the right way to do this with an appropriate data set. But you said just sort of putting that sort of filter on the previous study. I mean, presumably judgments were made when they analyzed the study. Maybe they didn't do the best, but to what extent are you kind of modulating it for each study as opposed to just kind of everyone has to fit into your approach?
Yes.
Just because that's very different from the way you normally think about a meta-analysis.
It is. So there are a lot of researcher degrees of freedom in terms of how to code the conflict outcome, how to code the climate exposure. And so we are letting researchers retain, or each paper retain a lot of those researcher choices about how to code conflict, what conflict to look at, what climatic exposure to look at, right? All we're doing is saying, you need to have longitudinal data. So we've just selected studies that have longitudinal data, and you need to plausibly account for confounding variables, right? And so we're going to do that using some sort of panel fixed effects analysis. Most of these studies are doing some version of that already. So some of them actually did not need much alteration. Often the only thing we're adding is adding these sort of lag terms that account for displacement or amplification, right? And in some cases, those weaken the results. In some cases, they actually strengthen the results. So to answer your question, Matt, we're trying to strike a balance between preserving a lot of the choices, the sort of structural choices the authors made about what outcome to look at, what exposure to look at. And we're just trying to use the same meta-analysis, the same statistical sort of framework. So yeah, you're right that this is different than some of the meta-analyses that you see, which just take results off the shelf, right? They don't worry about necessarily the statistical analysis that generated the results. To us, and especially in this, having looked at many of these studies, that is a mistake, because a lot of the variation for the same data set, you can get very different results if given the sort of statistical choices you make about how to run the regression. And so to us, a better way of doing this is to keep the regression that we're running fixed, and then let authors make choices about what outcomes to look at, what exposures to look at.
Great, Marshall. You got a question in the chat here too. It says market indices, e.g. DJIA, Shanghai Composite, the DE40 in Germany are virtually global in scope. To a large degree, market activities, let me see my screen here, anticipate and reflect issues concerned with climate change, conflict, political risk, and more. Would their inclusion as factors in your models potentially add interpretive value to your results?
Yeah, interesting question. So if you look at our samples here, a lot of our samples and a lot of our data on group level conflict comes from the African context, some from the Asian context. And at least my experience working in sub-Saharan Africa is that a lot of these sort of international financial aggregates their relevance for some of these rural African contexts is potentially limited. So I'm not sure that their inclusion would, and so I guess another way of putting it is, and I'll show you in a moment, we have, if the idea or the concern is that we need to account for local level variation in, let's say, economic conditions, we have more direct ways of doing that we can exploit in some of these settings. So we're going to try to do exactly that. I think as the comment suggested, maybe some local data on economic conditions could tell us something about what's going on here. We're going to do exactly that. Thanks. Okay. So clearly there's a lot of spread in point estimates. So one thing we can do is just take sort of the average, and here we're going to take precision weighted mean. So what's the mean effect across all these studies? We are going to weight. This is a weighted mean where studies that are more precise get higher weight. This is sort of a standard approach in meta-analysis. For precipitation, for rainfall, the precision weighted mean is dead on 0. So it looks like precipitation sort of on average has no effect. So we get some negative estimates. We see some positive estimates. The precision weighted mean is 0. For temperature, it's not 0. So we find a precision weighted effect of about 6. So sorry, here the units are to make these studies comparable. The other thing we have to do is convert everything into similar units. The units we use are percentage change in the conflict outcome per standard deviation change in the climatic exposure. So I think that maybe makes sense for precip. For temperature, we don't tend to think of temperature in terms of standard deviations. So there's that, but to make it comparable, we sort of need to use it. So our average temperature effect is 6% increase in conflict for standard deviation change in temperature. So if you think a really hot year is a 2 or greater standard deviation increase in temperature, that means on average a really hot year is associated with 10 to 15% increase in conflict, right? So to us, that's a meaningful effect. That's a pretty large effect. Okay, again, that's the average effect. There's a lot of variation. Let me come back to that variation in a moment. That's intergroup conflict. Here's interpersonal conflict. Here, the effects tend to be much smaller, but much more precisely estimated. A lot of our data here come from wealthier countries where we can put together pretty detailed data on interpersonal conflict. So this is often violent crime, murder, assault, domestic violence, things like that. And at least in some settings, these are pretty well measured in official administrative data, right? So here we have about 24 studies, about 20 studies, I guess, right now, 25 estimates from almost 20 studies. Again, effect sizes are smaller, but they're very precisely estimated. Most of these appear driven, again, by temperature, which is the best studied relationship. So hotter temperatures increase the likelihood of interpersonal conflict. And it's about 2% per standard deviation. So again, a very hot year, a very hot week, think of it as a 2 or 3 standard deviation event, then you get a 6% increase in these different types of conflict, right? So again, it's not doubling conflict, but it's leading to measurable increases in the occurrence of these different types of conflict. So results are actually fairly consistent for interpersonal conflict. Finally, for self-harm, and this is a more recent part of the literature, so looking at the relationship between climatic exposure, and in the worst case, suicide. So multiple studies looking at suicide, including some work that we've done in the US and Mexico. And here again, we see results that look more or less like the interpersonal results in terms of their averages. So 1%-ish increase in incidence of various types of self-harm or negative mental health issues per standard deviation change in temperature. Okay, and again, smaller number of studies here, some variation in the point estimates, but overall positive relationships. Okay, so I'm going to focus mainly on temperature. That's where the earlier study, our earlier meta-analysis and our studies here showed a more consistent relationship. It looks like the mean effects are positive, meaningful in a livelihood or economic sense, but there's a lot of variation, right? And so we first want to understand whether this variation is representing true underlying differences in the effect sizes across these settings. Is it true heterogeneity, or is it just sampling variation, right? Is it just the fact that a lot of these estimates are really noisy and that we can't really say statistically that the effects are different across settings? How do we think about that? So again, how do we separate true heterogeneity from sampling variability? What we're going to do here is estimate hierarchical models. If folks are familiar with this, economists have just gotten excited about these in the last few years. So my bias here is as someone trained as an economist who reads a lot of econ papers. A couple of really nice papers, Rachel Meager, Eva Vivalt, in the last couple of years have introduced these techniques to economists, but they've really existed for a long time in the statistics literature. Don Rubin, Andrew Gelman, and so we're going to follow sort of their cookbook on how to do these things. And basically, the idea here is, and I'm going to show you a couple of equations here, but it's useful for thinking about, and it's really a nice way to think about effects in these. In this or any other meta-analysis, right? So imagine we have a bunch of different studies, and each has an estimate of a treatment effect you care about. So here our treatment effect is the impact of a change in climate on a conflict outcome, right? So each one has an estimate, tau, k, and hat here means it's an estimate, right? K indexes studies, so we have K studies, 68 studies total. What we're going to say in these hierarchical models is the effect that we observe, the tau k that we observe, that is drawn from a distribution of some true effect, something that we don't observe, right, with some standard error, right? So think about there's the observed effect, and it is an estimate of what the true effect is in that specific setting, right? So I'm studying the impact of climate on conflict in Syria, right? I have an estimate from a study, and that's actually a draw from a distribution around a true unobserved effect, tau k. Okay, so that's for each study, and then each study's effect is drawn from a broader distribution, right, of true effects. And that thing has mean tau and some standard deviation, right? Okay, so we have individual studies with true effects that we don't observe, and these true effects are themselves drawn from this broader distribution, right? And so the idea here is you can write these things down as normal distributions, and you can estimate a model that from the data basically learns what the true overall average effect is across the study and whether those effects truly differ. So the sigma squared tau thing is the underlying true variance in the effects across the studies, right? And so you can see the hierarchy, right? So this is a two-level sort of hierarchy. You have the individual level estimates, and then you have the sort of group level means. Okay, and basically what this is going to tell you when you estimate these things is that if this variance is greater than 0, then there is true underlying heterogeneity in your effects, right? And that's that. If it's different than 0, there's true underlying heterogeneity. If it's 0, then that means all the effects have the same mean, and that all of the variation that you see in the point estimates is just driven by sampling noise in the sort of first stage in the estimation of individual level treatment effects. This has a nice mapping to external validity. So if folks are used to thinking about external validity, you hear this in applied micro talks all the time. how does your result in setting A, what relevance does it have to new setting B? That's an external validity question. Again, the variance tells you something about that, right? If this variance is close to 0, then that means the true underlying effect does not differ across settings, right? And so a study from one setting has almost perfect external validity to a study from another setting. If this thing is large, if there's true underlying heterogeneity, then you would be worried about external validity, right? Your study estimate from one setting is not going to be necessarily representative of what you might expect to find in another setting. This approach gives you a quantitative way of thinking about exactly that question. Okay. So if the model is right, and again, you're writing these things down as normals, you got to take some stands on sort of what the distributions look like. There are some nice things that come out of it, right? And again, I think of this as a way of sort of disciplining our understanding of whether these effects are the same or different, right? So this first thing is it can tell you what proportion of the overall variation in effect sizes across studies is just due to sampling noise, right? And that's basically going to compare your estimate of the underlying variance to the study-specific standard errors, right? So in settings in which these standard errors are really large and the underlying variance is really small, then you're going to say almost all the underlying variation is just coming from sampling noise, right? Versus a setting when your standard errors are really tight, right? Your studies are estimated really precisely, but your model says the underlying variation is large. There you're going to say, look, all the variation is coming from true underlying heterogeneity. Okay, so the model allows you to estimate that. It also allows you for each study to then update your estimate to get a posterior estimate of what the actual effect in that study is going to be, right? And your estimate, your best estimate is going to be some weighted average of the thing you actually estimated. So this is Burke 2009, right? The thing we ran before. So it's a weighted average of that and our estimate of what the overall average is, where the weights are proportional to how much sampling noise is in my study, right? So if my study was garbage and it was just all sampling noise, then we're basically going to give my study 0 weight, and we're going to say, what Marshall should have found in that paper is just the average effect across studies, right? So again, it gives us a way to think about not only across the sample, where's our variation coming from, but for individual studies, what was the likely effect in that individual study, given all the other studies that we observed in the data set. Finally, it gives you a best guess as to what, if you did a new study in a new setting, what's your estimate going to be in that new setting? So it's a really nice, again, way to discipline our thinking about where is variation in our effect sizes coming from when we look at a lot of different estimates of the same thing. Okay, I won't talk about estimation here. I'll point you to the Gelman, long Gelman chapter from which we followed to estimate these in the recent Meager papers, if you like the econ literature on this, which are quite clear on this. Okay. So we're going to estimate these hierarchical models. So I switched the notation here. Different papers use different notations. So sorry, here now mu is now the mean. I totally screwed this up. Mu is now the mean. So think of this as the mean effect across studies. Tau is now the standard deviation, right? So this is the true underlying mean. This is the true underlying standard deviation. If tau is 0, there is no difference in true effects across studies. If tau is greater than 0, there is a difference, right? Okay, so focus again on the intergroup. Our mean is close to what I showed you before, so 5 to 6. And again, this is in percentage point changes per standard deviation change in climate exposure. So a 5% increase in intergroup conflict per standard deviation increase in temperature. So that's the mean, what I showed you before. What we would estimate from the model is this has substantial true underlying heterogeneity, right? We can reject that the standard deviation is 0. In fact, it's quite large. It's almost as large as the mean, right? So what this would suggest is there's a lot of true differences across the studies. Same thing for interpersonal and same thing for self-harm. Although at least for interpersonal, the underlying variation is smaller than the mean, right? So there we saw sort of tighter standard errors. And when you see tighter standard errors and the effect sizes are pretty close together, yeah, you can get sort of tighter overall distributions here. So substantial, but across all of these, substantial true underlying heterogeneity. But at least for intergroup conflict, it suggests that at least over half of the overall variation in effect sizes that I showed you is driven by sampling noise. So this pooling estimate suggests that 60% of the differences are just sampling noise, right? Are just the really wide confidence intervals that we had on each of those studies, right? Less true for interpersonal and much less true for self-harm. So this suggests that actually most of the underlying variation is coming from true heterogeneity and not just from sampling variability. Okay, so what does this tell us? This tells us that of those wide variation in effect sizes I showed you before, they are unlikely completely driven by sampling variation. There's likely true underlying heterogeneity, and that is particularly true for interpersonal and self-harm. It's also perhaps somewhat true for the intergroup stuff. As you can see here, maybe 40% of the remaining variation is due to true underlying differences. Okay, the last thing that this technology can give you, again, is the updated estimates for individual studies. So the black points were what I showed you before for intergroup conflict, individual study level estimates. The underlying gray line underneath it is the standard errors on those estimates, right? The confidence intervals. The posterior estimate, a sort of updated estimate, would be in red. So for this Balkan and Sargenti, this first study, their point estimate was fairly negative, -5%. Our Bayesian model is going to tell us, actually, the true estimate in that setting is more likely 2%. So basically, the hierarchical model is going to be very skeptical here of negative estimates, negative and particularly negative noisy estimates. It's less skeptical of this one. This has a tight standard error, right? But overall, it's very skeptical of noisy estimates, and it's going to be quite skeptical of things that are either quite negative or quite positive, right? And so the term in the literature for referring to these are shrunken estimates. Often it's pulling these estimates towards the mean, and the amount it pulls them towards the mean depends on basically how uncertain the estimates are, right? So the more uncertain you are, the more you get pulled towards the mean. So if this is right, then this says it's actually in most of these settings, we're very unlikely to see the very large estimates you get in some of these papers. We're very unlikely to see large estimates, unlikely to see negative estimates at all. So only a few of these remain negative once we update our priors. Okay, so Matt, just making sure we go for 20 more minutes. Sorry.
I think we go to 3:45.
3:45. Okay.
Yeah, Marshall,
Perfect.
just a question about this. So I mean, the sort of shrunken. I mean, it's by construction, right? I mean, it's always going to turn out that way, isn't it? So
there will always be a little bit of shrinking unless the standard errors are literally zero. So the amount of shrinking is going to be a function of how uncertain your estimates are. So for intergroup conflict, we have a lot of really noisy estimates, and so you're going to get a lot of shrinkage, right? For interpersonal, I don't have the numbers up, but there we have a lot of really tight standard errors. And so when you have a tight standard error, the model actually pretty highly weights your estimate relative to the mean.
Right, but it's like as long as if the standard errors in a study tend to go up when your coefficient estimate tends to be further from zero, it's always going to shrink it like this. And that's a question, not a statement.
No, you're right. But the first part of your question doesn't necessarily have to be true. It's true under publication bias story, right? But there shouldn't be a relationship necessarily between the coefficient estimate and the size of your standard error, right? There often is, because there is publication bias, but like that, there doesn't need to be, right? But you're right. In practice, there's basically always shrinking, but the shrinking really is a function of how noisy each individual estimate is. So here we see a lot of study level shrinkage. Yeah.
Can I jump in with a quick question?
Yeah, please.
I don't want to get too deep in the nitty gritty here, but something I didn't understand is, are you treating all of these studies as if they're drawn sort of IID from that normal distribution? Or are you taking into account that there could be some dependence between studies in the same regions or of the same, subclass of violence?
Yes, that is a very good question. Not weedsy at all. Yes, right now we are assuming they are independent, which is incorrect. So you can build in a covariance between, like, we don't have a good way of sort of estimating how independent they are. I think you're absolutely right that the assumption of independence is wrong. What I think it will do would be to, in this setting, lead to further shrinkage, basically. It's a little easier to implement in the precision weighted mean setting, where we can sort of easily assign a sort of covariance between studies and then calculate the weighted mean. Yeah, so you're right. Right now we are assuming independence, and that's likely not correct. I think the implication is it will shrink things more. But it's a great point.
Thank you.
Yeah, no, thank you. It's hard to figure out exactly how to implement that because you got to take a stand on what that covariance looks like, and like what, do you do it based on number of sort of shared observation? Like how do you do it? Yeah. So open to ideas. If folks have ideas about the smart way to do that, we don't have any. Okay. So last bit, so there is true underlying heterogeneity, let's say. So that just tells us studies are different. It doesn't tell us why they're different necessarily. So can we understand why they're different? So can we explain or predict this heterogeneity? And you could imagine we could look at this in different ways, right? What I showed you before is the between study differences, right? We have these estimates from different studies. We're getting more and more estimates. We still don't have that many, right? So again, we have a few dozen for these different types of outcomes. So you're not super well powered to understand potentially many different sources of heterogeneity, but that's one way of doing it. The other way of doing it is actually looking within studies, right? So to the extent within different studies, we can observe sources of heterogeneity, moderators. Within studies, you actually might have a lot more data to do that. So imagine a lot of these studies are running these longitudinal fixed effects regressions at a grid cell level. So you have a grid cell by year, and Africa might have tens of thousands or hundreds of thousands of grid cells. You might have US counties by year and have 3,000 counties, right? And so in those settings, you have often very rich data on moderators of interest. And so actually have a lot more data and a lot more statistical power to understand heterogeneity. So we're actually so far going to focus, and what I'll show you today is looking within studies, these studies where we observe some of the moderators that we're interested in and study whether the effect of climate on conflict differs as a function of those moderators. But we hope to do both of these things. One is just sort of harder to figure out how to do it in a statistically powered way. Okay, so so far I'm only going to focus on one potential driver of heterogeneity, and because I'm an economist, I'm forced to focus on something about economic conditions as a key moderator. So that's what we're going to do. This is, of course, an economist's favorite potential moderator here. So why might the effect of climate on conflict differ across settings? If you believe that economic conditions are the thing that links climate to conflict, so you get worsening climatic conditions, these change economic conditions on the ground, and these induce individuals to start or join conflict. So that's the typical story that you will often see in the economics literature. It's a story about opportunity cost, right? So a worsening climate reduces the opportunity cost of joining a conflict. You need to put in like normal words, you need to put food on the table. Your crops have failed. This might be the only way to do it. These conflicts actually typically start with a very small number of people. So this doesn't have to turn every single farmer into a fighter. It just needs to turn a few dozen of them into such a thing, or have hundreds join a conflict, right? So just you need a few at the margin to make this decision. That's the argument. So again, I think there's some reasonably strong evidence of that this is one plausible channel, at least in the economics literature. You've also seen it in the individual level conflict. So it could be the case that tough economic conditions in a city or a location could make individual level conflict more likely when there's, again, some sort of downturn or some sort of triggering event brought on by the climate or by something else, right? I would say overall that this sort of hypothesis is consistent with the conventional wisdom you often see in the climate impacts literature. This is that there's something insulating about wealth, right? Wealthier populations are somehow less affected by changes in climate. And this is I would say this is a strong conventional wisdom that you see all the time. I think people, again, have different stories about why this might be the case. People can afford to undertake protective behavior. They work in sectors that are just fundamentally less affected by changes in climate anyway. But again, you see various flavors of this all the time. So all of these would predict overall that you see a basic heterogeneity as a function of economic conditions on the ground, right? So in wealthier locations, you should see less relationship between climate and conflict. And on some level, I think we already know this to be true, right? We have not seen, thank goodness, civil conflicts or civil wars in most wealthy countries in centuries, right? So if I were to estimate the relationship between climate and civil conflict in most wealthy countries, I would get a 0, right? Because we do not observe civil conflict in most countries, right? So variation in climate, which we have seen, has not induced conflict of that sort, right? So on some level, this has to be true. We are going to try to estimate on a more local level whether it's true in settings that we care about. Okay.
Hey,
So
Marshall,
again,
I don't want to affect your flow here, but
please.
I haven't been able to see some of the chats, but you got a question in here, another question. It says, this is from, let's see, my laptop here. This is from Thomas B. And he says, the linearly vertical shape of the posterior shows both lack of fit as well as virtually constant estimates. To me, this suggests revisiting the model assumptions, e.g. the distribution of normal errors. A different distributional assumption, e.g. the Weibull or the Cauchy, might be worth testing.
Yeah, I think that's fair. There's some choices you can make in the model and Cauchy. So the way you have to make assumptions or choices about what sort of distributions you assume about the errors, and I think you're right that normal might not be the best choice here. It's a great point. I'm not sure that what I showed is necessarily indicative of poor fit. I think what it's indicative of is, given those assumptions that, and given the large statistical noise, large confidence intervals we see in a lot of these studies, like, we shouldn't be surprised that a lot of those get pulled in towards a mean, right? Just because they're highly uncertain. But I think you're right that we should explore whether those results change if we change our assumptions about the underlying distribution. I think that's totally right. Thanks. Okay, so we're going to do this in 3 different settings right now. We're working on expanding this right now. This is actually some primary data analysis. So to make sure we can do this in a consistent way, we've gone back and reanalyzed gridded data across sub-Saharan Africa over the last 3 decades. This is, again, those data from UCDP that I showed you before. So this is gridded level civil conflict data. The grid size here is like a 50-kilometer grid. So these are geo-referenced conflict event data. So we're going to look at that as our group level conflict outcome, and we're going to look at homicide and violent crime in the US as our individual level outcomes. And again, we're going to try to estimate whether the effect size is the marginal effect, so the additional effect of an increase in climate on a conflict outcome, either civil conflict or violent crime in the US, whether that differs as a function of local level income, which we observe in the US, or local level asset wealth, which is the sort of economic characteristic that we observe in sub-Saharan Africa. So the county income level data, county level income data is just admin data in the US. In a place like Sub-Saharan Africa, we often don't have comprehensive data on these outcomes. So the data we are going to use comes from a whole different set of projects that I work on, which is a remote sensing, machine learning based approach to estimating local level livelihoods around the world, including in Sub-Saharan Africa. Happy to talk more about this. We have a bunch of papers on this. Here's one that we're going to use directly from last year, led by some great students. And basically here, we're going to take existing level data on economic characteristics on the ground. This could be local level asset wealth. So think of asset wealth as a summary index of the assets that you own: TVs, cars, radios, cell phones, your roof type, what your house is made of, whether you have electricity, right? We basically create an index out of that. Again, happy to talk more about that. That index tends to be pretty robust to what you throw in it. Ownership of assets tends to be highly correlated. And so we have some surveys where we observe that, and then we're going to train a model to actually predict that from various sources of daytime and nighttime satellite imagery, right? And what we show in this paper and in other papers that does a lot better than some of the things you see in the econ literature pretty prominently, just using nighttime lights imagery. So there's a lot of issues with nighttime lights, and it turns out using that in combination with daytime multispectral satellite imagery lets you do a very good job of predicting variation in asset wealth. So here I'm showing you a figure from this paper. This is Nigeria. We've done this now for all of Sub-Saharan Africa back to about 2003. So we have annual estimates of very local level asset wealth across Sub-Saharan Africa for the last 2 decades. And so that's going to be our sort of economic measure that we're going to use as a source of potential heterogeneity in Sub-Saharan Africa. So again, happy to talk more about this data set, but that's what we're going to be using. Okay, so here's the 3 different heterogeneity analyses. I am looking good on time. This is the last empirical slide. We see strong, so this is just run as a linear interaction, what I'm showing you here. We can do this non-linearly, and it gets a little bit noisier, but the overall sort of slope is the same. Basically, at low levels of income, we can be quite confident that the relationship is large and positive for civil conflict in Sub-Saharan Africa. So this is low levels of asset wealth, for homicide in the US, and for violent crime in the US. So I have bootstrapped this regression a bunch of times. Each line here is a different bootstrap. So this is, I think I ran it 1,000 times for each of these. So it gives you sort of a sense of the visual uncertainty. The dark line, if you can see it, is the overall sort of median estimate across those bootstraps. So the estimates at higher wealth index, at higher income levels, tend to be not statistically significant. So again, strong positive effects at low parts of the asset or income distribution, and then affects the decline towards zero at higher incomes or higher levels of asset wealth across both individual level conflicts. So again, homicide, violent crime, and civil conflict in Africa. So this is not a meta-analysis of existing studies. This is now, we're using data that have been used in those studies, and we're doing this ourselves. Okay, this is consistent with some great country level work. So there's a couple studies out there, a very nice study by Tivrat and colleagues in Mexico, by Timo Fetzer in India, that leverage various policy experiments to show that as in the Indian case, workfare, the INREGA program was rolled out across India. This broke the link between climate and conflict. So sort of a direct test of the income hypothesis here. Similarly, Progresa in Mexico, villages or localities that got Progresa saw less conflict as temperatures increased. So think of these results as consistent with a few other existing very nice quasi-experimental papers in the literature, right? So it looks like we do see strong heterogeneity by income. Now, I think we should be a little cautious about these results because income could be correlated with other things that are driving this heterogeneity, right? So we are not going to have perfect designs to be able to isolate the impact of income from other things correlated with income. Tivrat and Timo and colleagues, their designs, I think, are going to be a little bit nicer than these sort of cross-sectional interactions we have here. But again, overall, it's consistent with what the literature seems to be saying here. Okay. Let me just finish up quickly. So implications for future conflict. So hopefully I've convinced you that looking backwards, at least in some settings, we see pretty substantial relationships between warming in particular and various types of conflict, but that this effect might differ as a function of economic conditions, average economic conditions on the ground. And so effects seem to be amplified in lower income, lower wealth communities, either in sub-Saharan Africa or in the US. Okay, so what do we have coming down the pike? So we have a lot of warming, as folks might know. We remade the sort of standard, how much is the world going to warm up map in terms of standard deviations, because that's how we've done the analysis. And especially in the tropics, so this is the projected temperature increase by 2050 in standard deviations. This is the plot we made a few years ago. It's probably a little bit high right now. Temperature projections have come down a little bit, thank goodness. But basically what you see in the tropics is, been to the tropics or from the tropics, you know, the temperature just doesn't vary that much, right? The year-to-year variation is quite small. And so a degree or two increase in temperature is a huge increase in terms of standard deviations, right? It could be up to a 4 standard deviation increase in temperature, given historical variability that's just really tight in the tropics, right? So in terms of standard deviations, we expect massive increases across the tropics, and much lower increases in the much higher latitudes where the year-to-year variability historically has been quite large, right? So even though you're going to see more warming in the higher latitudes in terms of standard deviations, it's actually smaller. Okay, so if you believe the recent past can be a guide for the future, this would suggest we have a lot of warming coming down the pipe. Warming is rapidly going to push societies in the tropics beyond what they've experienced historically, right? And so we might think that could exacerbate conflict risk. But pushing back the other way is perhaps what I just showed you, right? If there is income heterogeneity, right? If we think that rising incomes could help break the link between climate and conflict, if development continues in the future, as it has in the recent past, then maybe that's a force pushing the other way, right? You have warming pushing in one direction and you have development pushing in another direction. So here's a map I just made quickly of the African asset wealth data we have. This is now aggregated to admin 2 level, but this is basically the growth in asset wealth over time as estimated from satellites. And a lot of places are growing really fast, right? You have many parts of East Africa, parts of West Africa that are growing at, 0.2 standard deviations per decade, right? Which is really impressive growth, right? So these places are developing quickly, and our estimates would suggest that that's going to, again, reduce the likelihood that a negative climate event triggers a conflict outcome. Okay, so as these two forces sort of pushing against each other, as we go forward here, our goal is to try to say something quantitative about those two forces and what the overall effects might look like in the future. That's not ready for public consumption yet today. So I'll just, I'll leave you with these maps. So let me wrap up here. Again, I would say fairly consistent evidence that higher temperatures can contribute, not always, but can contribute to conflict risk. Again, this seems, we see this across many different geographic settings, many different types of conflicts. And I would say the overall strength of this evidence has grown a little bit since the last study. Our average effects are maybe a bit smaller, but we have a lot more evidence saying that they are there. I think these effect sizes are meaningful. So a 5 to 10% increase or 5% increase per standard deviation is large, especially if you think that future climate change is going to lead to a mini standard deviation increase in temperature exposure, right? So a naive multiplication of those two things would suggest large increases in conflict. But again, pushing the other way is economic development, right? And so to me, this is at least somewhat comforting, the fact that economic development and the various things that brings can help break the link between climate and conflict. We see some evidence that that's the case. So really, it's going to be sort of a horse race, unfortunately, between a warming climate and hopefully developing economies and with, I would say, a sort of unknown net impact that we're going to try to estimate. So I will stop there. Thanks a lot for your comments. Have a couple more minutes and happy to hear more comments or questions and appreciate the attendance. Thanks.
Well, thanks, Marshall. Anybody who has any comments or questions, feel free to just unmute yourself and jump in.
Quick question, Marshall, if you don't mind.
Yeah, please.
I was wondering if you could do some of those plots of the study effect sizes as like scatter plots with either precision or the power of the study on the y-axis. It might be interesting to see if there's like a discontinuity near zero that would suggest, that there's some file drawer problem or selection publication bias in which studies are actually being put out there.
Yeah, thanks. That's a great idea. I think it would be a nice way to just look at the effects overall, but as a sort of one way of thinking about publication bias. I mean, what's funny is like often I think that's especially a useful way of thinking about the existing estimates that are in the published studies. Like we think studies might be selected on those estimates. Often our reanalysis leads to estimates that are quite different than what's in the published paper. So I think there would be less chance for publication bias in sort of our estimates just because of the fact that those were not often the published estimates. But I think you're right that there are a bunch of approaches for thinking about publication bias and the importance of publication bias or the existing of publication bias in these meta-analyses and so we need to do more of that. Yeah, thanks.
Anybody else? Well, thanks, Marshall. Very interesting. We've got, I think the room here, the weather here has probably scared people from the room, I see, but you got many interested folks online and obviously an important and interesting topic. And so I thank you on behalf of all the others for an interesting seminar. We look forward to the future results that you have coming down the line.
All right. Thanks, Matt. Thanks for having me. Thanks, everybody, for coming.
Take care. Bye-bye, everybody.
Take care. Bye.